Hello, Quantitative Methods class. Welcome to the very first lecture of our class. Um, for many of you, this lecture will contain a lot of review. Maybe you've had Psychology 1102, Introduction to Psychological Science. Maybe you've had Elementary Statistics. Maybe you've just had this material in science classes before. That's fine. In fact, if you're starting off this class with knowing some of this information already, that's wonderful. You're a leg up, if you would. Another thing is overlearning is never a bad thing. It's going to help this information stick with you from a long period of time. But many terms that we're going to use in this class again and again and again, I want to make sure that we know what those terms are before we continue on. All right, so let's go into our introduction to statistics, particularly psychological statistics, the statistics that we use in the science of psychology. And we're going to do two or three things across a couple of videos. First, we're going to do some basics of statistics. Why do we need statistics? Why is it important? Come up with some definitions of some of the basic terms of statistics. Then we're going to move on and talk a little bit about research methods. There is always a bit of a chicken and egg problem with how you teach research methods and statistics in psychology. You can't talk about research methods without talking about the statistics that you will use to analyze the results from those experimental designs. All right? And you can't talk about the statistical tests that you're going to use without knowing something about designing an experiment or designing a research study. So which one of these classes do you teach first? Do you teach research methods and then statistics? Do you teach statistics and research methods? Or do you combine the two of them? And universities across America and in Europe as well vary widely in what they do. In fact, I think UNG is the only school that I know of that does the statistics first and then research methods. Most people I see, at least in my perusal of other departments, teach research methods first and then do statistics. And some, like what I had in undergrad, is you have one giant class. So a 6-hour course where you're doing both research methods and statistics at the same time. It's a good way of doing them because you can talk about the research design and talk about the statistic at the same time, but man, is that pretty onerous to do at the same time. It's a pretty heavy-duty class for a lot of people. So how am I going to rectify this? We got to talk a little bit about research methods in this class, or otherwise we're not going to know when we use which statistic. It's going to be a theme of this class and something that I want to make sure that you know. The formulas for these statistics you can look up. Heck, some of these formulas, well, not necessarily in this class, but some of the more advanced formulas, I do not have them memorized. All right, I have a textbook, and I look up that textbook. Or, even better yet, I get the computer to do it, and I don't even look up what the formula is. That's not the important part of this class. The important part of this class is understanding what that statistic is doing, finding out when you need to use that statistic, and how to interpret these statistics. So the math behind it, not nearly as important as to the interpretation and when we do these particular statistics. So knowing something about research design will let you know when you need to use which of these statistics. So that's something that I want to drill into you guys' heads. And then we're going to finish this discussion by talking about different types of variables. What's the difference between a independent and a dependent variable? You've known that since elementary school. What is the difference between a continuous and a discrete variable? We'll talk about levels of measurement in this section. All right, so let's do some basics. First, let me give you kind of a roadmap about what we are doing in this class and compare it to maybe some other classes that you have had. If you have math, elementary statistics, you don't cover a lot of the meat and potatoes of this class. Now, the great thing about that class is it goes into probability, something that we are not going to touch at all. So if you know anything about Bernoulli distributions, or if you know anything about permutations and combinations, that's great information to know. None of that's going to be in this class. You probably talked a little bit about descriptive statistics, central limit theorem, null hypothesis significance testing. All of that's going to be in this class, and much more. But for the first maybe 2 tests of this course, you're going to have a leg up on everybody else because you have had this stuff before. What do I think of elementary statistics, at least how it's taught at University of North Georgia? Meh. That's kind of how I feel about it. Let me silence that noise for you guys real quick. Where was I? They teach you a lot of things that are good, but the bad thing, or relatively bad thing, is they teach you how to do everything with the graphing calculator. Now, the graphing calculator is a wonderful tool. It's expensive as all get out, but you're never going to use a graphing calculator in real life. Never. Any data set that you work in, if you are part of a business doing statistics in the real world, you're going to have that information on computers. The data set's going to be so big that you can't input it into that graphing calculator. Graphing calculator is useful for the statistics class, but it is useless in the real world. And that's why I do not want to teach you how to do these statistics using the graphing calculator. It's just not usable when you are getting with real world data sets. I'd much rather teach you a method of doing these statistics using technology that you're actually going to use if you end up getting a job that deals with some statistics. Okay, there, rant over. Psychology 1102. This class, if you've had it, is a hodgepodge of a lot of things. You might have covered, and hopefully you've covered some statistics, and that's going to be useful for you in this class, at least for the first test or so. But in this class, we're going to cover a lot more material than anything in those previous classes. We're going to talk a lot about analysis of variance, which is the way that we analyze experimental psychological studies, at least in modern psychology. Many times in psychology nowadays, our experimental designs are quite complicated. Anytime that we use an experimental design in which we don't just have one independent variable, and we have a control and experimental group, we're going to use an ANOVA. So if we just have the experimental group and the control group, we can use a simpler statistic, a t-test, more about which soon. But anything that's more complicated than that, we use an ANOVA. We're also going to be talking a lot about correlation and regression, which are techniques that we use when we're doing differential psychology, when we're looking at individual differences, let's say in personality, maybe in intelligence, if we're trying to predict some outcome based off of a variety of other variables. So we'll learn a little bit about that without going into some of the more advanced minutia with regression and correlation. That's the roadmap of what we're doing. All right, let's talk about some basic terms in statistics. First, a term that we're going to use pretty much every lecture is population. A population is the sum total of a group. It's everybody in a group that we're interested in. And a population could be of any size. I could look at the population of students in my quantitative methods class, which would be all 24 of you. All right. If I'm interested just in data from that class. So I could look at how many people, how many students took college algebra, for instance, or how many of you took elementary statistics. I would be examining the population there. And I might be interested in that if I am a professor. But many of the questions in psychology, we're not just interested in a singular classroom, but we're interested in all human beings, okay, all across the world. And we are interested in all voting Americans. Let's say that we're interested in pulling data about who you're going to vote for in an upcoming election, right? The population is everybody in that county, or everybody in that state, or everybody that's of voting age in the United States of America. All right, a population could be of varying sizes. All right, all Americans, all college students. Maybe we're interested in every student at UNG. Whatever we're interested in examining. All right. Ultimately, what we care about are qualities of this population, right? How many individuals in this population are male versus female. Maybe we're looking at measures of extroversion. Okay, how extroverted are all Americans, how extroverted is our class for quantitative methods, how good at problem solving are all UNG students. We're interested in these particular variables for a population. All right, and we can summarize these qualities, right? How extroverted all Americans are, how good at problem solving, what's the average SAT score for all UNG students, by looking at a parameter. A parameter is a number. It's a set of numbers, perhaps. It's a summary, sorry, let me back up. A parameter is a summary of a set of values from a population. So if I were to calculate the average SAT score for everybody in UNG, I'd be looking at a population parameter there. All right. If I wanted to look at how many individuals are going to vote for this political candidate in the state of Georgia, I'd be looking at a population parameter in that case. All right. It is a way of summarizing every single number in the population. When we are looking at a parameter, the way that we abbreviate it is with a Greek character. So anytime that you see a Greek character, I want you to think parameter. All right, and just to give you some knowledge here, this funky looking thing that kind of looks like a U, but has this little part right there, this is called mu. Mu, M-U. All right, mu is the population parameter for an average. All right, so anytime you see mu, this is the population parameter for the average of a set of numbers in the population. But parameters are not just means. I mean, most of the time we're interested in means, all right? But we could be looking at things like the amount of variability in scores. So maybe we're looking at how religious individuals are at UNG. Maybe it's the case that people vary widely in their religious beliefs, or maybe that people are fairly homogeneous in their religious beliefs. To look at the amount of spread in a particular variable, we're going to look at something like the variance or the standard deviation. If you don't know what these terms mean, you will soon, at least by next week. If we are looking at the population parameter for standard deviation, we're going to use this little signal right here, and this is a lowercase sigma. This is the population parameter for a standard deviation. And again, more about which soon. So lowercase mu, lowercase sigma. Anytime we see Greek characters, we want to think about a population parameter, a summary of every single person in that population. Also, populations are not just always people. Most of the time in psychology they are, because that's our subjects most of the time. But we could look at a population of frogs, a population of dogs, a population of cells, for instance, depending on which discipline in science that we're looking at. All right. So a summary number for a population is a parameter. How do we go about collecting a parameter or finding out a parameter? Well, we have to do what's called a census. All right, a census is a record of everybody in the population. We go out and we gather information about every single person in that population. This is easy to do for something like my class, or our class, I'm sorry. Right, it's only 24 of you. But how about all students at UNG? How about all human beings in existence? You can't do that. It is not feasible. You can't go and collect a census of everybody. It's just not possible. Even the United States government census, which is taking place right now, in fact, I just filled mine out, a lot of people are underrepresented. Many people don't fill out the census. It's not a true census in that regard. Statisticians have to estimate what individuals did not take the census to come to proper conclusions. So a census is nice to collect all the information of population, but many times we can't. There's a limitation, right? Trying to generalize findings of a study to all human beings, we'd have to collect data from all human beings, and that's just not possible. So it's incredibly tough to conduct a census to get some kind of population parameter for us to know some quality of the population. So what do? What we do is we draw a sample. A sample is a subset of a population. We're going to draw a particular subset. It could be of varying sizes, which is a certain portion of the population. And we're going to observe everybody in that sample. And we're going to calculate a number, some summary characteristic of that sample. And we're going to try to generalize the results of our sample to the population at large. Because ultimately what we care about is the population, all human beings, all students in UNG. We don't just care about the sample that we have drawn. We care about the population at large. That's what we're trying to infer about. All right. Not all samples are created equal. All right. Typically, the larger your sample is, okay, the more your sample up, the greater percentage your sample makes up of the population, the more accurate your sample is, or the more representative the sample is to the entire population. But that's not always true. Let me give you a good example of this. So in 1936, Franklin Delano Roosevelt, this guy over here, ran a presidential campaign against this guy over here, Landon. Okay, Landon, I even forgot what his first name was. But at the time, political polling was in its infancy. And one of the biggest magazines at the time was the Literary Digest. And they prided themselves on having the most data points for the most people returning information to them, polling who these people are going to vote for. So the Literary Digest sent their magazine out and asked their readers to write in who they were voting for the election. So the Literary Digest could make a prediction about which of these two individuals would win. And what they found is that by a landslide, Landon was going to beat FDR. That's what the Literary Digest predicted. All right. Now, when we look at who exactly won, the results are the exact opposite of that. FDR won in a landslide. I mean, that's why we know FDR's name, and we have no idea who Landon is. All right, let me tell you another story. There was a gentleman by the name of Gallup, Gallup, which might be familiar to you if you've ever heard of Gallup polling for political matters, same Gallup. And Gallup, instead of writing out to all members of a particular magazine, tried to get a sample that was more representative of all Americans. All right, so the problem with the Literary Digest was that everybody that was able to afford the Literary Digest was pretty wealthy. All right, and since everybody that wrote in was fairly wealthy, it wasn't a good sample of the population. It wasn't representative of the true nature of the population. Gallup, on the other hand, was able to gather data for individuals that didn't have that much money, poor, and individuals that had a lot of money in the specific proportion that they occurred in America. And by having a more representative sample, Gallup was able to predict that FDR would win in a landslide, and that's what ended up happening. All right, you can think of Gallup as kind of the old school Nate Silver, if you're familiar with Nate Silver and his statistical work. All right, so the important point to note here is that we want to, when we gather a sample, we want it to be representative of the population as a whole. We want the sample to be representative of the population, to contain all of the characteristics that the population has, all right? To contain the same percentage of certain subgroups. For instance, if in America there are 50% males, 50% females, we would want to make sure our sample was close to 50% males, 50% females, all right? If America is 60% Christian, 30% Jewish, 10% Muslim, and I'm just making these percentages up. That's definitely not the case of America. We want to make sure that our sample is of those characteristics as well, especially if we were asking questions about religiosity. All right. So we want to make sure that we have a representative sample, or otherwise the conclusions that we make based off of our sample, we try to generalize it to our population, are invalid. All right. Our research study is useless if we are unable to generalize to the population as a whole. Let me give you another example. Alfred Kinsey. All right. Alfred Kinsey was a zoologist that in the late 1940s and 1950s was very interested in human sexual behavior, something that was very taboo at the time. So some of Kinsey's surveys, some of his research was groundbreaking in the sense that no one was really asking about human sexual behavior at the time. And his books were very controversial. So one example of some of the statistics that Kinsey reported is he reported that for males, human males, that around 10% of all human males were homosexual, okay, or were gay, to use more modern terms. Now, everyone thought that that was a crazy statistic at the time, that a lot of people were just not open about their sexuality based off of Kinsey's research. But he vastly overestimated the number of gay individuals in America. Why did he do, or how did he do this? Okay, how did he come to this conclusion? Well, Kinsey interviewed 5,000 or so human males. So he had a large enough sample, but he only interviewed the individuals that wanted to talk to him about sex. Many people have a hang-up about sex, and so they're not likely to talk to some guy in a bow tie about their sexual preferences. So Kinsey's sample was unrepresentative of the population as a whole. And so if we look at his descriptive statistics, the means and so of preferences and sexual behavior, they're a bit off because Kinsey's only interviewing individuals that want to talk to him about sex, okay? Not all individuals, not the individuals that are more squeamish or don't want to talk to another person about their sexual behavior. And this is a lot of people in the 1950s and 1940s, as you can imagine. All right, so we want to make sure that our sample is representative of the population as a whole. Here's a good example here. Let's say that we have 5 different kinds of people based off of the color of their shirt. We want to make sure that our sample has the same percentage of people that have red shirts, green shirts, blue shirts, orange shirts, and purple shirts. All right. So we want to make sure that we don't just have people with red shirts, because then we have a very unrepresentative sample, and any statistic that we calculate from the unrepresentative sample isn't going to generalize to our population of interest. All right. So how do we make sure that we have a representative sample? Because this sounds like it's a pain. We got to make sure that we're measuring all of these characteristics of people. And what characteristics of people are important? Okay. Is it their religion? Is it their gender identity? All right. Is it their intelligence? Is it their personality? I mean, there's so many things that we need to make sure that the sample is representative to the population. All right. That sounds like it is an impossible task to perform. All right. Well, there's an easy way to do this. And the way to do this is via random selection. All right. There's 2 terms that we're going to talk about in this module that have a similar name: random selection and random assignment. Here is my warning to you right now. Do not confuse the 2. The 2 are different. Random selection is how we gather a sample from a population where the sample is representative of the population at large. All right. So for random selection, we create a sample, or we gather a sample in such a way that every member of the population has an equal chance to be included in the sample. All right. Everybody has an equal chance of being selected. All right. We might use a random number generator or something along those lines to do random selection. So let's talk about a couple of sampling techniques, and let's see if they're representative or not. Or let's say are we using random selection or not? All right, so let's say that we're interested in all UNG students, and we are asking preferences of, I don't know, maybe professors, what professors you like the most. Let's say that we set up in front of Chow, and anybody that walks in, we give them the survey to fill out which professors they like the most. Are we using random selection? Does everybody have, in the population, all UNG students have an equal chance of participating? No, it's obviously that it's not, right? Why isn't this the case? Well, many people don't go to Chow, all right? Chow's only on the Dahlonega campus. If you live off campus, you probably don't go to the Chow Hall. So it would be a horribly unrepresentative sample, all right? Let's talk about some other things. Maybe we go to one of the dorm halls and we go into each dorm and have people fill out a survey. Again, this is unrepresentative because what about the students that live off campus? All right, they would not be included or have an equal a chance of participating in our research study or filling out our survey. How about if I were to grab the UNG directory and start with the students with the last name A and go down and select those students? Would that give me a random sample? Now that would be a better approach than these two, but it's not random selection because only individuals that have a last name that begin with A are going to be selected for our research study. All right, so we need to make sure that we use random selection to get as representative of a sample as possible. Many times this is not feasible. The subjects in most psychology studies are sophomores at in a university setting, and this is unrepresentative of most human beings. All right, the term sometimes that psychologists use to refer to their subjects is WEIRD, which is an acronym. Western, most psychology research subjects are from Western universities, not Eastern universities. Educated, it's the E there. Obviously, they're in college, right? People that drop out of high school, for instance, are not likely to participate in research studies. Industrial, so we're looking at more industrial societies than rural societies. Democratic nations, that's the D there, so more likely to be democratic in that regard. So the subjects that we have for our research studies in university systems, not the most representative of all human beings, right? So we have to think about some of the limitations of our research studies, and we'll talk about that a little bit later. All right, when we calculate a summary of some characteristics of a sample, we call that a statistic. All right, we call it a statistic. We are going to use Latin letters, which are the letters that we use typically, A through Z, to denote a statistic. So if ever you see like a little s, this is the sample standard deviation, the standard deviation of our sample. If you see X bar, which you'll see many times in this class, or if you see M, I will use both of those. Textbooks like to change their notation frequently. But if you see X bar or M, we're talking about a sample mean. All right, and we take these sample statistics and we infer what the population means, the population standard deviation. So whatever parameters we're interested in of the population are from these statistics that we calculate. All right, here's a good illustration of the general principle of how we do research, okay, how we're conducting our statistics. All right, we have our population of everybody that we're interested in. Could be all Americans, could be all human beings in the world. And ultimately, we care about this population parameter. Maybe it's a population mean. That's a very easy thing to look at. So we can't measure everybody from the population. It would take too much time. It's not feasible. So we use random selection to get a subset of these individuals. And then we measure these individuals on the characteristic that that's of interest. And this is our statistic. maybe it's a sample mean. And then we infer from this sample mean what the population mean would be. All right. This sample statistic is likely to be somewhat similar to this population parameter, but there might be some error just due to, maybe it's just due to random selection, that we selected individuals that are more likely to vote this one candidate than this other one. Maybe we randomly selected individuals to be smarter than the general population. All right, there's plenty of sampling errors that might occur, so we're not always 100% confident that this one value for our sample statistic is exactly the same as what our population parameter is going to be. There are two categories of statistics. There are descriptive statistics, and we'll spend the first 4 lectures or so talking about descriptive statistics. Here, we just care about, I guess it's kind of obvious, describing the data. We're not talking about, does this treatment of depression work better than this other treatment? We're not inferring anything. We're just trying to describe a population in some way. All right, how many males versus how many females? What's the average SAT score of everybody at UNG? All right. Many times, if you're working for like a Fortune 500 company and you're a data scientist, a lot of times they're not interested in inferences of things. They're interested in just maybe describing some data. Okay, how many people are satisfied with their job? How many people are unsatisfied with their job? All right, these are very important questions for the executives of a company that they might ask you. So, how do you do these descriptive statistics, and how do you present these descriptive statistics? That ends up being very important. All right, because you could present the data in a way that makes the data look very good. You could present the data in a way that looks very bad. But what I want you to do is try to present the data in a way that is the most fair, that's the most accurate. We'll talk a little bit about that when we talk about visual displays of data. 1 second. All right, so we have descriptive statistics. We'll talk a lot about these next week, and we'll talk about how to display these. But typically, we're just telling you what the average is, what the standard deviation is of something is. We are graphically representing the data. We're not answering any scientific questions. Descriptive statistics are important for psychology, but by far the most important, and the majority of time that we're going to spend in this class, we're going to deal with inferential statistics. So here we're using sample data to make general estimates about what's occurring in the population. All right, so we're using our sample statistics to infer what's going on in the population. All right, does this drug help treat depression? Does it dramatically reduce the amount of depression in a particular group? Do people that own a dog have lower anxiety than the general population? Okay, these are questions of inferential statistics. Does this brain training program actually stave off the consequences of aging? All right, if we give you this brain training program, is that going to lead you to be more cognitively sound longer in your life? These are very important questions in psychology, and they all are going to use inferential statistics. Again, we're taking a sample statistic and trying to infer what's going on in the population. That's what inferential statistics is all about. Let me give you an example of this. So let's say that we are doing a experiment on using some kind of psychotherapy, and we have a control group that does not see a therapist, and an experimental group that does see a therapist. All right, and we see after the study that the experimental group has a lower score than the control group. Our question is, does our experimental treatment work? Are we 100% confident it works? You might be thinking to yourself, well, maybe it is lower, but ultimately with inferential statistics, our question is this difference due to a real effect, or is this difference between our experimental and our control condition just due to chance? Just by random selection, if there is no effect, sometimes we might pick the less anxious people for our experimental group and the most anxious people for our control group. All right, so maybe this difference is due to sampling error. Maybe it's due to a real effect. With inferential statistics, we calculate the probability that we find a difference of this magnitude just due to chance, just due to sampling error. And if it's very unlikely that we get a difference of this magnitude, given if there were no differences between the two conditions, then what we say is it's probably the case that there is a true effect, that there is a statistical difference between our experimental group and our control group. I used a lot of terms there that you might not be familiar with. In module 6 or 7, we're going to talk a lot about statistical significance. So don't get bent out of shape right now. But what I want you to pay attention to right now is that just because we have a difference here in our experimental or control condition, it could just be due to chance, could be due to sampling error. Maybe we've randomly selected the less anxious individuals for our experimental group and our most anxious individuals for our control group. Okay, how do we make a determination of whether or not this is a true effect and not just due to random sampling? Okay, not just due to some kind of sampling error. Think about how we're going to, or think about how you might try to tackle that problem. All right. Okay. So if we are conducting a study and we see a difference like this, we have to come to some kind of conclusion whether or not it's due to a sampling error. If we had population parameters, all right, if we had populations, all right, so maybe let's say that we have two groups. We have all males in humanity and all females in humanity, and maybe females scored a 6, maybe males scored a 7, and we have every single one of them, and we want to come to the conclusion about whether or not males are more anxious than females. We would have to say yes. We don't have to do any statistics, any inferential statistics, if we have the population parameters. All right, we can just compare them, and if there's a difference in the population parameters, there's a true difference in the population because we know what the population is at that point in time. All right. So let us stop this video right now, and then we'll continue with the basics of research methods in the next video. All right. Thank you, guys. Bye-bye.